Okay, today I'm going to show you how you can build a beeping oscillator. Well, you can build a non-beeping oscillator if you want, using a dual H-bridge driver chip such as the MX1508 or MX1616H or even the L298n. They're very inexpensive when you buy them in quantities like off AliExpress. Anywhere from like 26 cents up to 90 cents, just depending on what vendor you select and how many you're buying. This is a large printout of what the board looks like to make it easier than trying to stare at the actual little teeny board that's here. And this is the small speaker that I used in my Vanishing Shadow project. You can see if you add a baffle to it, it makes it a lot louder. There is a slight turn-on delay. I will turn the battery pack off to it here so you can see. I'm going to turn the pack on in 1, 2, 3, on. So as you can see, you got about 4 or 5 second delay before the cap that does the beeping part, not the continuous tone, but the gating of the tone, charges up and starts cycling. So, if you've watched my other videos, and if you haven't, I'll put links to them down below. Basically what we're going to do is it's a dual H-bridge driver. We're going to use each one independently. We're going to basically wire them up as inverters. And once you have an inverter, you can make an oscillator by adding a feedback resistor and a capacitor, an RC circuit to it. And this upper one selects the continuous frequency of the tone itself. In this case I used a 0.1 capacitor and about a 200K resistor to give me the buzz tone that I wanted. Then the lower one I'm using to gate that tone off and on. And the rate at which it gates off and on, I decided to use a 10 UF capacitor and about a 390K feedback resistor. Now to actually make it gate, because the oscillator that's producing the tone does both positive and negative waveforms, we need to make sure that we're only supplying the speaker what it needs, in this case ground, at the particular part of the timing cycle. So I'm running it through a diode. This resistor up here before the speaker is simply to protect the speaker. This small little speaker that I'm using here is only rated at a 1/2 watt. And of course, being that this chip can deliver a 1.5 amps of current, and in this case I'm running the circuit on 5 volts. Inside the robot I had a step-up regulator to give me enough voltage for the flashing eyes. So I've just tapped off that 5 volt supply to run my beeper as well. So anyway, I put in a 20 ohm resistor to get the level down to the level that you're hearing here on this video. Of course, if you had a bigger speaker, like a regular large PM speaker or something, you don't need to put a resistor in at all. Go ahead and stick the whole 1.5 amps into that speaker if you want to. It'll be plenty loud, trust me. So what else can we say? I think if you watch the other videos, I'll cover how the logic works in these things. But the long and the short of it is there are 2 separate circuits in this chip. The upper one, input 1 and 2 and output 1 and 2. If both inputs are positive, it throws it in what they consider a braking state, which this is normally meant for driving motors. So both outputs will then go low, which would short the motor wiring together. So if a motor was trying to freewheel and act like a generator, those wires being shorted together would cause a braking function. In other words, stop it right away. There's also an open circuit function. If both of these, input 1 and 2, are both made low at the same time, then you get an open circuit in there, no connection at all. But anyway, in this case, we're going to take input 1, we're going to bring it up and tie it to the V plus for this whole chip. Then we're going to take input 2, we're going to tie it to our capacitor and to ground. Here's ground off pin 1. And then we're going to take a feedback resistor, which could be a pot if you wanted to vary the tone. And you're going to bring it all the way around to output 1. That'll form if you were to just listen, if you were just to connect your speaker up to hear in either positive or negative, it doesn't matter since that's an AC signal, you would hear that continuous tone. No gating at all. So the low one then I make up as my low frequency oscillator, so I can get a beeping, and you do exactly the same thing. Take what its input one is, in this case it's called 3, and just tie it to V plus as well. And then 4, I've got a 390K feedback resistor to its output, which is right here. And I'm using about a 10 UF capacitor for my timing resistor because I wanted to get, roughly about a 1 second, thereabouts, beep tone out of it. And as I said before, the diode to the speaker is to give me the gating, because otherwise it wouldn't matter if this output was high or low. Since this is an AC signal, the speaker would just be on continuously. So by putting a diode in there, only when this goes into the negative side of the cycle, as you can see I've got the cathode in here and the anode going towards the speaker, will the speaker beep. Now if they wanted to kind of reverse that, where you wanted the speaker on the whole time and then just briefly go off, you could flip that diode around, put it in the other way. Or if you don't want it on, if you want it on all the time, and like I said before, you can just connect the speaker directly up to either positive or negative, and you'll have a power oscillator that's on all the time, and use the bottom for something else or use it for nothing at all.